Hello, this is Mr. Phelps, and what we're going to do is we're going to go over your phase diagram notes. This is a phase diagram. What a phase diagram does is it tells us what state of matter we have at every pressure and temperature change. What we're used to is we know that at a certain temperature, like at 0 degrees Celsius, we're going to have ice. And at 100 degrees Celsius, we're going to have steam. But what we can do with a phase diagram is we can change the pressures and the temperatures and find out what state of matter we have. So that's what we're going to do right now. What I want you to do is you're going to take notes in your phase diagram, and here's our first notes is on a phase diagram. This part of the phase diagram, these are going to be the solids, these are going to be the liquids, and these are going to be the gases. Let's find out by looking at our axis how we can tell this. This axis here is going to be pressure. The pressure I'm going to choose is atmospheres because this is what we normally live in. And this temperature is our temperature. This axis here is going to be temperature. It's going to be measured in Celsius. And we know that temperature increases this way. So we can make this like -10. We'll make this here 0. We'll make this here 100, and we'll make this 110. Notice what's happening. Our temperature is increasing. So it makes sense as our temperature increases, we're going to go from solids, liquids to gases. Okay? But look what's odd here is we could have a solid. Let's say that this temperature right here is -5. At -5, we could have a solid here. But if I decrease the pressure, if pressure starts going down and I keep taking pressure off, these molecules now have enough energy to escape and become a gas. So that's what we can use, but look at by using our phase diagram. So let's look at the parts of the phase diagram. So we already know this is solid, this is liquid, these are gases. This is my temperature scale here, our pressure scale here. For our phase diagram, if I'm going from a solid to a liquid, we know that we are doing this is melting. And if we go the other way, from a liquid to a solid, we are going to be freezing. All the way along this line. If I'm crossing a line going this way, it's always melting. Crossing this way, it's always freezing. Okay? What if we're going from a liquid to a gas? Well, a liquid to a gas, we know that that is boiling. What if we go the other way? You don't hear this word as often. Condensation, condensing. So all along this line, if I'm going this way, I'm boiling. If I'm going this way, I'm condensing. Okay. Now what if I'm going across this line right here? If I'm going from a solid to a gas, this is a word you don't hear very often. That's sublimation. Sublimation is going straight from a solid to a gas. We had this in our lab yesterday with the air fresheners. The air fresheners, you put a solid out and they will sublimate away to a gas. And dry ice does this also. You put a piece of dry ice out, it will just sublimate. It turns straight into a gas without ever becoming a liquid. And then the opposite of sublimation is called deposition. So anywhere along this line, we've got deposition going this way, sublimation going this way. Okay? Now, what if we have, let's concentrate on this right here. Let's act like this is 1 atmosphere. Now this makes sense to us because we live at 1 atmosphere. So as temperature goes up, we expect our solid to become a liquid And if we increase our temperature even more, we expect our liquid to become a gas. So that is what we're used to. So we will call these the normal boiling point, and this would be the normal freezing point. And so this is, I'm not choosing water here, so this is just some, if it was water we'd be at 100. I just made a chart up. This could be any type of a substance. This substance, if this is 1 atmosphere, then this right here is going to be our normal boiling point. I know, again, this is my normal boiling point because I found out this is my boiling line. Okay, at any of these pressures it can boil, but at the pressure we live at, 1 atmosphere, at that temperature, wherever that 1 atmosphere meets, that is called the normal boiling point. Now if I went up into the mountains, look what happens. As pressure decreases, look what my boiling point does. If I go up to the mountains, this will start boiling down here at maybe like 50. Okay, so what if I start increasing my pressure? I push down on a liquid even more. Well, if I push down on a liquid even more, it's going to be harder for it to boil, and so we'll have to increase our boiling point. This is what happens in your car radiator. Your car radiator, it says caution, under pressure. They put that water under pressure so that the boiling point is much higher. It has a better chance of cooling your engine. So instead of boiling at like 100, it will boil at 100 degrees Celsius. It could boil like 150 degrees Celsius because it's under tremendous amounts of pressure. Because someone knew from a phase diagram, if I increase the pressure on a liquid, its boiling point increases. Okay? And then the last thing I think I need to tell you is this point right here is a pretty cool little point. Notice that this solid liquid line, the liquid gas line, and the sublimation line all come together right here. And so at this special temperature and this special pressure, of course it varies with each substance, if you were at this temperature and this pressure, you would see the triple point. You would see all the gas, you can see gas, liquid, and solid at the same time. That's very unusual to happen because obviously, you know, when you're boiling water, you're going to see the liquid and we'll call it, you'll see the gas. When ice is melting, you'll see the solid and the liquid. If dry ice is sublimating, you'll see the dry ice, and I guess you can say you see the gas. But at this point right here, you'll see all three exist. Tomorrow, I'll be giving you a demonstration. I'll let you see all those different points, all those at the same time with some dry ice. So that will be all the notes I need to tell you. So what I need you to do now is use this information to answer the questions on the packet that I gave you.